All right, this video is going to show you guys how to do the 5.3 individual quiz, our most recent quiz that we did. In question number 1, and these were half a point each for those 6 problems, we just wanted you to identify what would be the best strategy to find the missing theta or x value, the missing variable. In part A, it's a right triangle, so that gives us a hint that we want to use sine, cosine, tangent, or Pythagorean theorem. But since we're finding an angle, then we have to use the second button on our calculator, so that tells us we're going to use inverse. From this angle, we have opposite, and we have the hypotenuse. So if I think of toa, opposite hypotenuse tells me it's sine, but because I'm looking for an angle, it is inverse sine. In part B, it is not a right triangle, so that tells me I'm either going to use the law of cosines or the law of sines. Excuse me. I can easily find the missing angle here by doing 180 minus 50 minus 32, which I think is 98. And now I know an angle and a side across from one another, which tells me I'm going to use the law of sines. Okay? Next, in part C, again, it is not a right triangle, so I know I'm going to use one of these two. And because I don't know any angles or sides across from one another, I know it's going to be the law of cosines. For parts D, I'm back to a right triangle. And again, I'm thinking SOHCAHTOA or Pythagorean theorem, and I'm just trying to find a missing side, and I know the other two sides, so I know that that's Pythagorean theorem. E and F are also both right triangles, so again, I'm thinking Pythagorean theorem or SOHCAHTOA. Okay, I don't know two sides here, so it's got to be SOHCAHTOA, and I'm not finding an angle, so it will not be inverse. That is opposite. This is hypotenuse, so again, it's sine, but this time it's the sine ratio instead of the inverse sine. Again, inverse sine is when you're finding an angle. For part F, right triangle, so I'm thinking SOHCAHTOA. I'm looking for a side, not an angle, and this part is adjacent, and this part is the hypotenuse. Okay, so C-A-H, cosine ratio is the best tool for that triangle. Okay. Number 2 asked us to actually find the perimeter. In order to find the perimeter, 14 plus 16 plus x, of course we have to find what x is. Because this is not a right triangle, I am going to either use law of sines or law of cosines. I do not know an angle and a side across from each other, and I can't find a missing angle, so I have to use the law of cosines. Okay, so remember, whatever angle you know is angle A, and the side across from it is little side A. Those two are B and C, and it doesn't matter what order you put them in. Okay, so little a, or x, you can think of it as either one, is equal to 14 squared plus 16 squared minus 2 times 14 times 16 times the cosine of 43. Now, remember, all of that stuff can go into your calculator at one time. Okay, because the variable is by itself on one side. So 14 squared plus 16 squared minus 2 times 14 times 16 times the cosine of 43. And I get that a squared equals 124.35. And to find what a is, I'm going to take the square root of my previous answer. And I get that it's approximately 11.2. Okay, remember that's this part, but it asked me to find the perimeter. So I have to add 11.2 to 14 and 16. I get a total of 41.2. And I just would say units because there aren't any other units written. Okay. In question number 3, they want me to find 3 things, but they do tell me in order which one to do it in. So if I'm looking for side C, it's a right triangle. I know 2 sides. I'm trying to find the third side. This is just Pythagorean theorem. Okay, when you do 15 squared plus 22 squared You get 709 equals c squared, and so the square root of 709 is 26.6. Okay, that's little c. Okay, so if I'm trying to find angle A here, but I know these two sides, I'm looking for an angle. I need to use the second button. I need inverse trig, okay? That's opposite. This one is adjacent. So I'm going to use inverse tangent, or tangent of A is equal to 22 over 15. And if I want to find what A is, I'm going to hit second tangent, 22 divided by 15. Okay, second tangent, 22 divided by 15. And I get approximately 56 degrees. Okay, and in a right triangle, once I know 56 degrees and 90 degrees, I can just do 180 minus 90 minus 56, and I get 4 makes 60, 34 degrees for angle B. Okay. Next, question 4 has 3 triangles. This is a right triangle, and again, I'm looking for a missing angle, so I am going to be using inverse of something. Okay. This one is adjacent, it's right next to. This one is hypotenuse. So I'm going to use the cosine of x is equal to adjacent over hypotenuse. So I'm going to type in inverse cosine, or second cosine, 31 divided by 48. And I get that x is approximately 48.7 units. Okay. Part B, I do know an angle and a side across. First of all, it's not a right triangle, so I'm thinking one of the laws, law of sines or cosines. Because I know the two across from each other, I want to use the law of sines. So sine of 40 degrees divided by 5 is equal to the sine of 60 degrees divided by x. And remember, when I cross multiply here, I am putting the cross products equal to each other. So x times the sine of 40 is equal to 5 times the sine of 60. Okay, some of you are trying to turn this into a fraction. That's not how you do it. Now to get the x by itself, I want to divide both sides by the sine of 40. And so I can type all of this into the calculator at once. Okay, x is approximately 5 times the sine of 60. Remember, I want to finish the parentheses before I divide by sine of 40, or I can use the fraction button. I get approximately 6.7 units. Finally, part C, again, is not a right triangle, and so I can't use SOHCAHTOA, I can't use Pythagorean theorem, but I can use the law of either sines or cosines. And because I don't know an angle and a side across from one another, I do have to use the law of cosines again. We did that on the front. Okay, so again, A is what I know, so I'm going to be finding little a, and those are just B and C in any order. So x squared is equal to 8 squared plus 20 squared minus 2 times 8 times 20 times the cosine of 130. I just squeezed it in. Okay, and again, because there are no variables on the right side, I can type all that in together. 8 squared plus 20 squared minus 2 times 8 times 20 times the cosine of 130. And I get 669.69, and again, that's x squared. So now if I take the square root, I get approximately 20, okay, well this is oh yeah, this is a side, 25.9. Okay, that one was an angle, so we could have said about 49 degrees. Okay, last question on your quiz was number 5. It says a surveyor wants to calculate the distance from points A and B to an inaccessible point C. These 3 points form a triangle. Okay, so I'm just going to make a triangle, any triangle. I'm going to call it A, B, C. Check. I kind of check so I know I've read through and taken care of that. Okay, because point C can be cited from both A and B, he knows angle A is 53 degrees and angle B is 61 degrees. In addition, the distance from A to B is 142 meters. What are the distances AC, Okay, so that one's AC and BC. So first of all, what I want to do is I want to find the missing angle. It's not a right triangle. I can't use SOHCAHTOA. I can't use Pythagorean theorem. So I have to either use the law of sines or law of cosines. And the easiest thing to do here is 180, oops, not 1980, 180 minus 61 minus 53. And I get 66 degrees for angle C. So now what I'm going to do is set up the law of the law of sines, because I know an angle and a side that are across from each other. So I'm going to say sine of 66 over 142 is equal to the sine of 61 over, you could say little b, or in the problem it asks for the distance from A to C, so I'm just going to say AC. Okay. When I cross multiply, 142 times the sine of 61 is equal to AC, that's just one variable, times the sine of 66. And then I want to find what AC is, so I'm going to divide both sides by the sine of 66. And I'm going to type it right into my calculator. Again, some of you like to use the fraction button. I think that's a great idea. 142 sine of 61 over the sine of 66. And I get 135.9. So AC is approximately 135.9 meters. Okay, and then if I want to find BC, I'm going to use the same strategy. I'm still going to use these two numbers that I know, sine of 66 over 142. This time, I'm trying to find BC, so I should use angle 53. So the sine of 53 over BC. I'm going to cross multiply. 142 times the sine of 53 is equal to BC times the sine of 66. And again, I want to get the BC by itself by dividing both sides by the sine of 66. So I'm typing this into my calculator. 142 sine of 53 and the parenthesis divided by sine of 66, and I get approximately, BC is approximately 124.1 meters. Okay, and hopefully that was helpful today.